We are about to see now a simple benchmark running on the Parallella prototype system. The benchmark calculates the sum of 16 Fibonacci series, each is 200 million elements long. The program is first run on the host, and then it runs accelerated by the 16 cores Epiphany accelerator. In this prototype system, the host CPU runs at 800 MHz, and the Epiphany chip runs at 100 MHz clock speed. This is the main program's code. The main function includes the code that loads and initializes the Epiphany chip with the Fibonacci kernel. Then it starts measuring time using the Linux wall clock, taking the time for the host to complete the calculations and then for the Epiphany to complete it. Here we see the Epiphany side computation. This kernel runs on each of the 16 cores independently. You can see how it communicates with the host via a mailbox. The mailbox is a small region of memory that both Epiphany and host use to exchange information. Running in an infinite loop, the core waits for a signal from the host by polling the inbox. Once the signal is detected, the calculation starts in a 200 million iterations loop. The result is then written back to the host via the outbox. And here is the host side computation, which is similar to the Epiphany side computation. Both programs were compiled using the same GCC command line options. Here we see how the host executes the calculations using the Epiphany device. With the Epiphany SDK comes the eHost API, which encapsulates the control and read and write operations to and from the device. You can see the eRead and eWrite APIs, which aren't much more than simple memcopies. So before starting the calculation, the host waits for the Epiphany to be ready. Once it is ready, it writes the seed to the Epiphany's inbox and sends a go signal to the cores. Then it calls the busy mailbox and waits for the result to be ready on the cores. When they are ready, it reads the result from the mailbox and adds up the 16 thread results. Let's see the benchmark running on the prototype system. First the host calculation, then the Epiphany's calculation. And you can see how a much slower Epiphany achieves a much better performance than the host. On the final Parallella boards, the Epiphany will be clocked at about the same speed as the host, so you can imagine the possibilities.